Everyone has heard of lithium-ion batteries. These batteries are now in our cell phones, laptops, cameras, watches, and other gadgets. The first commercial lithium-ion batteries were produced by Sony. Although they have large energy densities, they take a lot of time to recharge. On average, a laptop can take 3 hours to recharge. What if we can reduce that number to a matter of seconds? That's where supercapacitors come in. The first supercapacitor with low internal resistance was developed in 1982 for military applications through the Pinnacle Research Institute and was marketed under the name PRI ultracapacitor. Then they thought, what if we can use this for fast charging applications? Supercapacitors have very high charge and discharge rates. It can charge and discharge in a matter of seconds, and unlike lithium-ion batteries, they virtually have unlimited recharge cycles. Let's say we have two containers that store water. One is big, but it has a small hole for water to come out. The other one is small, but it has a giant hole for water to come out. The first container represents lithium-ion batteries because they have big capacities, but they charge and discharge slowly. The second container represents supercapacitors because they have small capacities, but they charge and discharge rapidly. Supercapacitors have energy densities of 10,000 watts per kilogram, and they can operate in temperatures of -40 degrees. Lithium-ion batteries have energy densities of 2,000 watts per kilogram and can only work in temperatures only as high as 40 degrees. Supercapacitors cost $2,400 per kilowatt hour, and lithium-ion batteries cost $500 per kilowatt hour. But in the long term, supercapacitors are cheap. Let me explain how supercapacitors work. Supercapacitors use electrostatics instead of chemistry. Inside a capacitor, there are two electrodes which are metal coated by a powdery activated charcoal. They use charcoal because it's porous and it has low density, which makes it an ideal material. Both the plates are soaked in an electrolyte and they are separated by a very thin carbon insulator. The porous electrodes are like sponges which collect electrons. Each electrode attracts the opposite charge, and this happens at a very fast rate. Supercapacitors usually have a nominal voltage of 2.3 volts. Many might ask, what is the difference between a regular capacitor and a supercapacitor? A regular capacitor stores electrical energy directly by an electrostatic field created between the two plates. Due to this, they can't hold as much as energy as a supercapacitor. Some people on the internet have said supercapacitors are the next batteries, but they are wrong. If we want to increase the capacity of a supercapacitor, we need to expand the separator, and by doing this, the time it takes for electrons to cross the separator increases, thus increasing the charge and discharge time. Scientists are trying to find alternative materials to increase the energy density of supercapacitors but not decrease charge and discharge times. Because of this, capacitors can only work with batteries but not replace them. Recently, Tesla bought Maxwell Technologies. They are one of the best manufacturers of supercapacitors in the world. Some people might wonder about the application supercapacitors have in electric vehicles. Together, batteries and supercapacitors can help in fast charging EVs. An average Tesla takes 12 hours to charge fully, but with supercapacitors, they can charge fully in 30 minutes. They can also regulate the power they supply for better circulation. Supercapacitors can also help in acceleration of a car. Due to their fast discharge capabilities, we'll be able to accelerate faster. In many gas vehicles and hybrid vehicles, there is an important use of supercapacitors. For example, the Mazda 3 and 6 have a system called the I-loop. They use supercapacitors to store energy that is being lost in braking. When a vehicle brakes, the energy is converted into kinetic energy, and which gets stored in supercapacitors in the form of electricity. This gives it a bit more range. Supercapacitors are definitely the future, but they can't immediately replace lithium-ion batteries. Comment down below what you think. Don't forget to subscribe and like the video. Thanks.